Starting right now?
Yep, we're live. You're not in it, you're hiding.
No, I'm putting on my sock.
And you're putting on your sock. Hey guys, we are live. I see two of you have signed on. Let me share my screen with you. This is Freddie. He'll be coming in and out the whole night, I bet. We're going to go here first. And we can make this bigger. Oh, except I forgot my Epic pen again. I pinned it on the bottom. Perfect. Let's get the Epic pen. Tonight is actually going to be super, super easy and low key simply because this unit is going to be quick. So tonight is going to be the shortest, probably one of the shortest nights. There's half of Freddie's head. Hello, Lexi. Good to see you there. I'm assuming you're Lexi. Let's see. Why can't I write to you? There we go. Hi. Okay, so I'm just going to get started because I know that you're going to watch this video later and be able to catch up anyone who's coming in a little bit later. So I did call some of your families, emailed all families to let them know about the review sessions and to let them know that we have a big review on Monday after school. So hopefully you won't have any problems doing that. I also told them that you need your devices to watch these videos. I thought it was Alexi. Oh, but I just really want you to do well. All right. Hey, Sammy too. Welcome, welcome. So I'm hoping that you have your books with you. And if you have your books with you, you should open to Unit 4 circles. And a lot of these things are going to look pretty similar because they're literally what you've already copied down in your books. And first and foremost, we have our types of circles to know. Now, the book this is the book I made from what Georgia said that you all need to know. They actually list 24 qualities about circles. And it's a whole lot of stuff. And I think next year I'm going to make the kids write even more than I made you guys write because some of it is pretty darn interesting. That being said, let's cover the things that really matter. So first and foremost, we have the central angle. We know it's the central angle because it's at the center. We talked about inscribed angles. And when we did this before, we talked about inscribed angles being arc to angle, divide by 2, angle to arc, we multiply by 2. You've also learned about internal angles. We know that they're internal angles because they form on X. And here we have our X here. Basically, for internal angles, we are going to add these intercepted arcs. And then when we divide by 2, it's going to give us one of those angles. And given that one of those angles and the other angle are vertical angles, they'll actually give us both angle measures. And finally, it's external angles is our last type of angle. And again, we know it's external angles because the point is outside the circle. All right, next coming up, you've got this. It's a little bit deeper into the central angle. Like I mentioned, the central angle, the next page in your notes, has the vertex at the center. And as you can see in our lovely diagram here, vertex, center, done. Again, it has the measures are the same. So one thing I did notice is some of you did a great job of drawing the pictures, but you maybe didn't do a great job of writing all this extra information down. So it might be really important for you to just go ahead and make sure that you have central angles equal the same. I think I might have also gone over that kind of verbiage at the beginning of this semester. I was like, central angles are the same, even though technically S and C are 2 different letters of the alphabet. They have the same starting sound, right? He says yes. And so we got central angles are the same. Okay. Next, coming down here, we have our inscribed angles. And again, as I modeled to you earlier, we know that inscribed angles, here's our central angle, here's our inscribed. Now, here's one of the things that's funkity-dunkity for you to remember. If by some chance we had a central angle that shared the same pink arc, this arc would be twice the size of that angle. And this is what I mean, Jelly Bean. Basically, what I'm going to do is I'm going to be like, I'm making this number up. Let's say this is 40 degrees. Okay. Well, if we remember angle to arc, we multiply by 2. Remember, angle to arc, we multiply by 2. So 40 times 2 is, Freddie? He says 80. He's correct. So this is going to be 80. And then we learned on the previous side that the central angles, this would be a central angle because even though I am a horrible colorer on the computer, why am I using the mouse and not my finger? We know that central angles have the same measure as the arc. So this is going to be 80. So this relationship of the inscribed angle and the intercepted arc with the central angle, the inscribed angle is going to be always half of that central angle if they share the arc. If I had to put money on something, I would put money on a question like this on the EOC for sure, possibly even the district assessment. This is the first unit that I'm covering that's going to be on your district assessment because it's unit 4 and unit 4 is going to be on your final. So a central core belief in geometry is that when an inscribed angle and a central angle share an arc, the relationship between the two is half. The inscribed is half the central angle, or the central angle is 2 times the inscribed angle. Moving on. Now we've got ourselves some interior angles. So you're looking at interior angles now on your sheet. Remember, as I said at the start of this, interior angles are what form that X. Because of the X, we do have our vertical angles here. So those 2 angles will end up being congruent, as will these 2 angles here. And if you have one of them, dude, it's super easy. All you're going to do is like use 180 to find the other one. So if you knew pink, you could find yellow. The formula is you're going to take 1/2 the intercepted arc. So as an example, here would be this arc. Here would be the other arc. We add them up and we take half. Same thing if we were going this way. We'd add up the 2 yellows, divide by 2, and we're going to get it. Here's the thing. Inscribed, interior, exterior angles, you always will end up dividing by 2 when you go arc to angle. The difference is that for inscribed, you just divide by 2 and do nothing else. For inscribed, you add and then you divide by 2. And for exterior, you subtract and you divide by 2. And speaking of exterior, boom, here's our exterior. You wrote this down on your paper already for sure. Or 160, some of you turned in your projects. Congratulations. Why is my tool not working? Here's the difference. So for exterior, you're going to subtract and then divide by 2. One more time. Inscribed, you just divide by 2, arc to angle. Interior, you add first. Remember, I told you interior angles form an X that kind of look like a plus sign. So that reminds us to add, divide by 2. And then for exteriors, we're going to subtract, divide by 2. Okay, you did some special angles. Here we go. Some special angles is if you have a tangent, that's what happens is the tangent will always be perpendicular to the radius. And what does perpendicular mean? It means it forms right angles or 90-degree angles. Okay, this is a concept I expect that you're going to see on the EOC. It's one of those central concepts is the tangent and the radius forming a 90-degree angle. The other thing you learned is that if you have an inscribed angle that has its endpoints at the diameter of the circle, that angle is also 90 degrees. The reason is a circle has 360 degrees. When we divide 360 by 2, we get 180 degrees. And when we have 180 degrees, and this is an inscribed angle, inscribed angles, we said angle to arc, we divide by 2. 180 divided by 2 equals 90. The last thing that you're going to see, this again is one of the core concepts. So I would expect that you're going to see it on the EOC and I would expect to see it on the district assessment. Granted, I have no idea, but I'm just going to say expect because I think it's important to know. Whenever you have a quadrilateral, the opposite angles are 180 degrees. Technically speaking, the opposite angles are supplementary. Supplementary. Oh yeah, your dinner's on the counter. All right. Sad break. Next, tangent lines. We're going to talk about lines. So first talked about angles. Now we're going to go into some of your lines here. Tangent lines touch the circle in exactly one place. As a reminder, you drew this beautiful picture all over again. Ooh, that got big pretty quick. Other interesting things about tangent lines is if they form a hat, which all tangent lines form hats. Here's our hat right here. These 2 lines, these blue lines are exactly the same. Okay. So you might have something come up where you need that. Okay. Honey, don't forget to pray. Okay. Next, Woo, I did it again. Okay, so we talked about parts of the circle before. This was on a pink sheet that we did in class. We know that the radius is half from the center to the exterior point. So one endpoint is on the exterior of the circle. One endpoint is the center. We know that a diameter is 2 radii put together, or one line. We know that the point of tangency, here's another radius, happens and it touches the circle at one point. And we just learned and we're reminded that that one point makes a 90-degree angle. You learned that a chord starts and ends on the circle, and you learned that a secant goes out to C. And that's what this is. Secant goes out to C. Okay, then there's a whole lot of relationships. If it's inside the circle, you learned that part times part equals part times part. That looks kind of funny, but basically it's like this line here times this line here equals this line times this line. Okay, it's just a relationship that they have. You also have learned something about parallel lines, and that intercepts the arcs. Here's something also really cool. Whenever you have parallel lines, and it probably makes sense, the distance between here and here obviously is going to be exactly the same, and that is going to be your height. Whoa, don't look at that. Height. Okay, so if you see anything that says parallel lines, I want you to think that it has the same height all the way through. Okay, down here we have this. Remember, I taught you about like, oh, I just hurt myself. Oh, I just pricked myself, and I just made my skin green turn purple. So wow, I'm multi-talented. Whenever you have ow, ow, oh, sad face, ow. You learned it is outside times the whole. So they did we equals we, but you learned ow because of like the spinning wheel. So you're going to have this outside piece here. And we're going to do an example of this, times this whole thing equals the outside piece here times this whole thing. Okay. That same rule works down here for tangents. Here we have our ow. I just pricked my finger. Let's change it to red because ow, it hurts. I pricked my finger. Here comes my blood. That's a little bit cryptic. But anyway, this is ow. So again, we have our outside here, which is A. Remember, I used to even have you do it like this. Our whole thing is A. Here, my outside is B, and my whole thing is whatever B plus C is together. Okay. Ow. Ow. Down here, we had, oh yeah, if you had 2 chords, this is just another one of those lovely rules that we like to throw at you. If you have 2 chords that have the same measure inside of the circle, their corresponding arcs also are equivalent. Look, it's kind of like a Pac-Man that went to the dentist and his mouth is too wide open. And the last one, if a diameter radius is perpendicular to the chord, the diameter radius bisects the chord. And basically that would just be true no matter where the line was, as long as it was perpendicular to the chord, because it would in essence create a perpendicular bisector. That might be all the questions. Let's see. Oh no, we have arc length still. Drat. You know what? Let's come to arc length after we do some more questions. Now we're going to go here. Nope. We're going to go here and we're going to click on U1, Q4. Okay. So here we have our questions. Let's take a look. So right now you should be looking at your papers that I passed out. Now, most of you have Unit 4 questions. If you do not have the Unit 4 questions, I will end up uploading them into the comments of this video so you can download them. And right now, I recommend just at least at a minimum writing the answers on a separate piece of paper. You are going to need to put this in your notebooks because remember, your notebooks are going to be due the day of your test, the afternoon of your test, whatever day you take it, Wednesday or Thursday. I have certain questions in each section I'm looking for to make sure they're done. And that becomes a grade. If you turn it in on the day that you take your test, not the day earlier because you need it the night before to study, but if you turn it in after you take the test that same day, I'll give you 12 bonus points based on whatever's done. Now, if you only turn in half the questions, half 12 points on top of 50 is a 62. You might as well finish the questions first. The reason is my goal is that you have all the questions done because it's critical that you know these questions before you sit for the EOC. That's what the growth mindset does. That's going to build your confidence because you're working toward it. And like Sammy and Lexi are here watching the video right now. What? Okay. What is the measure of POQ? Well, it tells us PQ is, let's do pen tool. It tells us PQ right here is 70. We know that POQ is right here, and we know it's at the center. Well, because we have it at the center, we know that it's the same measure because it's a central angle. Oh, look at that. Center, same, central. So this is 70. That means this is also 70 degrees. Then it says, well, what's the relationship between POQ and PNQ? Well, before we can figure out PNQ, we have to know what it is before we can talk about the relationship. Because they share the same arc, remember we talked about this earlier tonight, this has to be a 35. And we know it's a 35 because it's an inscribed angles. Inscribed angles are half the intercepted arc, so half of 70 is 35. But I told you that whenever you have a central angle and an inscribed angle, in this case, you have a pink central angle with a blue inscribed angle, the pink angle, the central angle, will always be 2 times the measure of the inscribed angle. So you could say the measure of angle POQ equals 2 times the measure of angle PNQ. The other thing you could write is you could write 1/2 the measure of angle POQ. Whoops, don't do that. POQ equals the measure of angle PNQ. Either way works. Okay. So therefore, what is the measure of PNQ? We already solved that. 35 degrees. What? Pause for the applause. Just kidding. Here we go. Next section. In the circle P below, AB is a diameter. I'm being attacked. I'm being invaded. Do you want to say hi? He does not want to say hi. In the circle P below, AB is a diameter. So I'm just going to draw my little diameter here. Boom, 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 boom. AP. Wait, AP? No, AB is the diameter. Well, because it's the diameter, we know that from here to here, this is 180 degrees. And well, we know other things too. Let's see what they want us to figure out. They want us to figure out, oh, they tell us that APC is 100. So if that's 100, we know that this is 100. Because this is the diameter, we know this is 180. We know that a circle has 360 degrees. So I can take my 360, subtract 180. That gives me 180 degrees left for this side, of course. We know one side is 100. So we're going to subtract 100, and that means 80 is this other side. If this is 80, that means this is also 80. Okay, then it says find the following. Well, the measure of angle BPC, oh, dude, we just figured that out, 80 degrees. The measure of BAC, here's B. Oh, angle BAC, hold on. Oh, that's this one. BAC is this whole angle here. Well, because the intercepted arc is 80, and we know that this is an inscribed angle because A is on the circle, half of 80 is going to give us 40 degrees. Then it wants to know the measure of arc BC. We just did that. That's 80 degrees. And they want us to know the measure of arc AC, which we've already determined before is 100. See how easy it is if you just draw the picture and then put the numbers in? Like, holy moly, you just get it right away. All right. Hope I can go a little bit faster because this is all stuff that I personally taught you. Next question. In circle P, DC is a tangent. Oh, DG is the tangent. Hello, tangent DG. It says that AF is 8. Okay. EF is 6. BF is 4. And EG is 8. They want us to find 2 things. They want us to find CF and they want us to find DG. Well, to find CF, let's make this blue. Okay. Remember, it was part times part equals part times part. So I'm going to do, let's call this X. So we would do 8 times X equals 6 times 4. 8 times x is 8x. 6 times 4 is 24. 24 divided by 8, Freddie Prince? Oh, he multiplied for us. I said divide. 24 divided by 8. That's one of your factors. You know that one. Three. We'll come back to you for another one. 3. So we know x is 3. So that's just what this is. CF equals 3. Thank you, sir. Can you please add 8 plus 6 plus 4? Now we have this one. Let's figure out our next one. Our next one is ow. I just pricked my finger. OMG. Ow is outside. Here's my outside. And what's my hole? And here we have to find the outside and the hole. You got it for us? Yepers. 8 plus 6 plus 4 is 18. He added all these numbers up for us. Here, our outside piece is 8. So now we have our 2 numbers there. Here, we don't know what our outside piece is. That's what we're discovering. So we're going to leave it as x. So now for our other piece, we have x times x, which is going to equal 8 times 18. You have time to do one more problem for us? 8 times 18. This is going to be x squared. I think it's 196, but I think I might be wrong. Oh, no, I think it's 216. Oh, I was way off. 144. Holy moly. Good thing he was there to check us out. Now we have x squared equals 144. So we're going to take the square root of x squared, and that's going to give us 12. So we know that. Wow, that looks really awful. DG equals 12. And let me just fix that. This is a 3. CF equals 3. There you go. We just did that problem. Woohoo! Let's keep going. Next question. In this circle, AB is tangent at point B, and AC is tangent at point C. So right away, we know that these 2 lines are the same. I don't know if that's important for this problem, but we do know that. What is the measure of angle BAC? So they want the measure of this angle. Wow, that's a whole lot of work going on. Okay, first and foremost, we need to figure out what this arc is. The way that we figure out this arc is we're going to take 48, and remember that we said angle to arc, we multiply by 2. So Freddie's going to hook us up with 48 times 2. This one's times. Then 2. 48 times 2. Oh, equals. This enter.
96.
Yeah, 96. Perfect. So now that we know that this is 96, we know that this arc is 96, and that makes this angle, the central angle, also, whoops, too big, also 96. Now, we learned that, and I told you this is one of the central things that I expected to be both on your district assessment and your EOC, is that whenever you have, oh no, that's not always the truth. Hold on, what am I missing? I'm going to say I was going to tell you the opposite sides are going to be supplementary, but all of a sudden I'm having a brain fart, so let me double check. 96. Since BAC is a subscribed angle, use the measure of angle BOC to find the measure of BAC. No, I was right. See, I doubted myself. So because this is 96, because this angle touches the circle, all you're going to do is you're going to take 180 degrees and you're going to subtract 96. What do we get? Yep, 84 degrees. So there's our answer. 84 degrees is the measure of angle BAC. Now, you could have done a lot fancier. You could have also done it once you found the 96. you could have been fancy and gone like 360 degrees minus 96 and gotten this arc. And then you could have done exterior angles. So we would have done 360 minus 96. Oh, yep, 360 minus 96. I think it's 264.
$264.
Okay, cool. Here's my co-pilot right here. Want to say hi?
Hi.
Hi. Okay, 264. So now we know this arc is 264. So we can use exterior angles, and we can do 264 minus 96. Which I think is going to be 168.
168.
And then remember, for exterior angles, we subtract the arcs and then we divide by 2. So 168 divided by 2. If we did it correctly, we should get 84. Boo-hoo-hoo, we did it. We got it right. Good for us. Great job. Okay, so that it was U4Q4. Let's go on to another one that I just kind of blinked at us. What? Circle P is dilated to form P prime. Which statement is always true? Well, I have talked to you about this 1,000 times. Whenever you have dilation, okay, we know that the scale factor and the rate is always the same. So I think I did this problem on another page, but let's look at it one more time. Here's our circle P. Because it says dilated, we could get a new circle that's smaller, or we can get a new circle that's larger. Okay, so is it true that the radius of circle P is equal to the radius of the little circle or the big circle? It's sometimes true, but it's not always true. Is it true that the chord is greater? Well, sometimes it's greater, but it's not always greater. The same thing for the diameter. That doesn't always happen. What always happens is the rate or the ratio. That always happens. That's the whole premise of circles being congruent. Hello. All right, let's moving on to the next question. U4, question 6. Here it says in the circle shown, BC is a diameter and the measure of arc AB is 120. So we're trying to find ABC. The first thing we have to do is think, okay, a diameter creates how many degrees? 180. So Freddie, you going to do some more math for us? We need to do 180 subtract 120. What'd you get?
I'm not done yet.
He's not done yet.
60.
He got 60, which is correct. So here's our 60. So we know this is 60 degrees. Then I told you a gazillion times, we're looking for ABC. Tell me about this arc. Well, we know that arc to angle, we divide by 2. So now he's going to take 60 and divide by 2. You can probably do that in your head. 6 divided by 2. He's too focused.
30.
Yep. 60 divided by 2 is 30. And that's your answer. Below 30. Trash can. We're going to keep going. You guys are almost done. Halfway done. Even though this is ridiculously long. Okay. Oh, we're going to have to go back to arcs to angles before I show you that. Okay. Now we're going to go back, switching back to arc length. When it comes to arc length, here's a couple things that we need to know. First of all, we already know that 2 pi r. First of all, this equation is on the formula sheet, so you don't have to memorize this. Anytime you have theta, that's the angle that we're talking about, okay? Arc length measures the outside. It measures the crust of the pizza. That's different than the area of the sector that measures the whole pizza slice, okay? Arc length measures the crust. Area measures the pizza, the whole or arc length measures the crust, area measures the whole pizza. All right, so let's take a look. What is the ratio of the radius of circle B to the ratio of the radius of circle A? Holy moly, this is a long one. Okay, so let's look at A and B. Ratio of the radius of circle B to the radius of circle A. Well, remember that I always told you it goes new divided by old. Hey, Aaron. And I'm pretty sure that ja is Jalen, but I might be wrong. Okay, I told you for letter A, it's new divided by old. That was a core thing that we talked about earlier. So because it says radio, because it says radius as opposed to ratio and radius combined, we have 10 is our new radius and 7 is our old radius. So what is the ratio? The ratio is 10 over 7. Then it says, what is the ratio of the length of the intercepted arc in B to the length of the intercepted arc in A? Oh, this is a long, challenging one. I'm going to write it down here. Again, it's going to be new over old, but instead of it being a fraction, I'm going to write it as a division sign. So we have our new, which is 50 pi over 9. Nope. 50 over 9 times pi divided by 35 over 9 times pi. Well, right away, our pi's cancel. You probably remember from back in the day that whenever you divide fractions, I don't think you've learned dividing fractions yet, right? That you multiply by the reciprocal. Okay. When we do this, our 9s cancel and we would be left with 50 over 35. You might have to watch this video one more time. Then we're going to see, what do both of these have in common? Well, they both are divisible by 5. 50 divided by 5? 10. 35 divided by 5. How many 5s are in 35?
6.
That would be in 30. 7. And what do we know about what we got for choice A in here? Compare the ratio. So this is 10/7. So what do we know about the ratios? They're the same. Essentially, what we're doing is we're proving that all circles are similar. I'm going to delete these notes so we have more space. You will probably have to rewatch this to write all this stuff down. Okay, but let's keep going. Next, I have D. What is the ratio of the radius from circle C to the radius of circle B? So the circle C, it says still the radius. So now we have 12 and 10. So for letter C, we're going to put new over old because no, it's new over old, which is 12 over 10. Okay, that would reduce down to 6/5. 6/5. Then it wants us to do the same thing with the arcs. So we have our new, which is 20 over 3. Now, we already learned that the pi's are going to cancel, so I'm not even going to bother doing that. And I'm not going to bother writing divided by 50 over 9 because I know I'm going to just flip it over anyway. So I'm going to do it like this. 3 goes into 9 3 times. I can cross out the 10. So I've got 2 times 3, which is 6, divided by 5. Okay. If I went fast, I'm sorry. You could have just multiplied everything across and reduced it, but that's just kind of how I did it. Basically, what I did is I reduced the 3 and the 9. I reduced the 10, and then I just multiplied 2 times 3 and got 6, and then I had my 5. What do we know about these? Oh my gosh, are we surprised? They're the same. Based on your observations of circle A, B, and C, what conjecture can you make about the length of the arc intercepted by a central angle and the radius? Well, I would hope you say something along the lines of when circles, such as circles A, B, and C, have the same central angle measure, the ratio of the lengths of the intercepted arcs is the same as the ratio of the radii. Basically speaking, arcs, radius, ratio the same. Okay. Arcs, radius, ratio the same. And then what is the ratio of the arc length to the radius of each circle? That one, basically, we're going to have to take this and we're going to have to divide it by 7 because we're going to take the ratio divided by the radius. So really that's going to be 35/9, okay, divided by 7, which is really multiplying by 1/7. So this is going to give us 35 over 63 pi. Okay. Which reduces to, if we divide both sides by 7, can you do 63 divided by 7? 35 divided by 7 is going to give us 5. 63 divided by 7 is 9. So this is our ratio for our first one. Let's change colors. This, I highly doubt you're going to see on the EOC, but I'm just going to do it for you anyway. Again, here you have your 50 over 9. This time we're going to multiply by 1/10, which is the same thing as dividing. I'm going to reduce each of these by 10. So, oh, look, I get 5/9 pi. Surprise. That's for circle B. Change color to green. And then here we're going to do the same thing. 20 over 3 times 1/12. How could I reduce this? I can do 3 here. This is going to become 5. And then there's your 5/9. So what is the ratio to the length of each thing? Blah, 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 5/9. I would be highly surprised if you saw a question that went to all this detail. I really would be. But I put it in there. It was in your EOC book. So now you've seen it. Okay, we're almost done. Look at us being awesome. All right, you ready to still help us out? Okay, we're going to do area of a sector. The formula for area of a sector is, leaving my mind, pi r squared theta. Pi, remember we did this in class. Area of a sector is pi times the radius or radius squared times theta divided by 360. So it tells us that if x is 50 degrees, find the area of the shaded region. This I can suspect them being silly about. Here's 50 degrees. Because this is 50 degrees, we know that this is a central angle because the vertex is at the center, so we know it's the same. So now we know that theta is going to be 50. So all we're going to do is pi. Because it doesn't tell us to use 3.14 for pi, we can just do it this way. So Freddie's going to take the calculator. Do you want to still help? 8 times 8 times 50. 3020? 33,200. And now take that number and divide it by 360. 360. There's going to be a pi here. What do we get? Let me see. Oh, it's all right. I have it right here. This one we're going to have to reduce. We're going to reduce by dividing by 4. So we have got 320 pi already reduced by dividing by 10. Now I'm going to reduce by dividing both top and bottom by 4. That's going to give me 80 over 9 pi. Okay, done. Let's look at the next one. Hey, oh, Dejan. Dude. Okay, let's keep going on. Next question. Okay, I think we're almost done, right? 3 more questions, then we're Gucci. All right, circle E. Okay, now it wants to know the length of CD. Because it says length, we're going to go like this. We know that the formula is 2 pi r theta divided by 360. We know it because it's on the formula sheet. You don't have to memorize it. Woo, woo. We're going to do, can I have the calculator, please? Are you going to do it? 2 times 12 times 145. 3480. Okay, that's going to be divided by 360. Okay, now I'm going to just reduce by taking that out. These are even numbers. Let's see, 12, 15. Oh, I could do this. Look, 4, 8, we can divide by 3 to start. So this is going to be 348 divided by, actually do 348 divided by 6.
58.
58? Really? 58. Okay. Oh, can you divide it by 58 divided by 2?
28. 29.
29. There's our answer. Choice C. We did it. Cool. All right. What's the area? Ooh, this is one that they probably are going to give you something like this on the district assessment and on the EOC because it checks two concepts in one question. It checks your ability to know to subtract to get this arc, and it checks your ability to use area of a sector. So Freddie's going to do 360 360 minus 75. And the reason why we're doing this is a circle is 360 degrees, and we're going to subtract 75 degrees from 360. $285 maybe?
285.
Perfect. So we know that our theta is actually going to be 285. Don't do 75. It's there to trick you. Don't be tricked. Okay. The reason why it's 285 is because the shaded region is this whole thing. That's why we needed to find the 285 arc. Because it wants area, we're going to do pi is going to come over here. You're going to do 9 times, I got it. You want to keep doing it? 9 times 9 times 285.
$23,085.
Wow. Now that is all divided by 360. So watch this.
23089.
Oh, 23089? 23,085. Wow. Over 360. Here comes my math hack. Could you please do 360 divided by 8? See how these all have 8 in the denominator? So what's a good chance the denominator is going to be 8? 45. Perfect. So we divided this by 8. Now he's going to take 23085. 23085 divided by 8. Oh, wait. Divided by 45. I misspoke. Sorry, guys. Whoops. Good thing you can rewind. Okay, the reason why we're going to divide both of these by 45 because we notice that the denominator is 8. I hit the wrong button. 23085 divided by 45. And the reason why we're doing it is we know that 45 is a common factor, but we're assuming it because these denominators are 8. We're 5 or 45.
513.
Woo, 513. Look at that, babies. We got that. Boom, pi right here, the choice D. Okay, let me summarize that one more time. Here for this question, we took 360 and we subtracted the 75 degrees because we needed to get this whole arc. When we did that, we got 285 for this arc. Then we used the formula pi r squared theta, and we plugged in 9 for the radius, theta for that, and all of that's divided by 360. We got this ridiculously huge number. Who in the right mind wants to reduce 23,360? Not me. So we math hacked it. We looked at the denominator here and we're like, dude, if we have to get to 8, what do we have to divide 360 by to get to 8? So we did 360 divided by 8 and got 45. And we learned that 45 was the number that we needed to divide by. So if we divide the denominator by 45, we're going to divide the numerator by 45, and that's where we got 513. And I know I said that fast because I know you can watch it again. What? All right, last question. And this should be familiar. I'm pretty sure this exact question was on a previous assessment. Here you've got a wagon wheel. And with your wagon wheel, your bicycle wheel, and it says that there's 10 congruent central angles. Well, that means that there's 360 degrees. So 360 divided by 10 gives us 36 degrees. So we know that each one of these, boom, shebang, 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 is 36 degrees. It says that the diameter is 18. Look at them trying to get you all cuckoo for Cocoa Puffs. 18 is the diameter. You got to turn that baby into a radius. We're going to divide by 2. 18 divided by 2 is 9. So now we have our theta is going to be 36 degrees because it wants to know 2 consecutive spokes. So like this spoke and this spoke, what would that be? What would this be right here? So our theta is 36. Our radius is 9. Now we're going to use a formula. Pi, 2 pi r times theta divided by 360. We're not using pi r squared theta because it's not shaded in. We're only wanting the crust, the pizza crust. So here we go. We've got 2 times pi times our radius, which is 9, times 36. Freddie's going to hook us up one more time. 2 times 9 times 36 times 3.14. 2 times 9 times 36 times 3.14. And I've got ginger at my legs. We got a lot going on.
36 and
2 times 9 times 36 times 3.14 equals 2, and then hit divide. 360. Whoops. Yep, 360. That's perfect. This is his first time using a scientific calculator. Nope, go back. And 360. One more. Make that a 6. Yep. Now type 0. Enter. What do we get?
5.652.
5.652. Does that look like something very familiar? It does. 5.7 inches. You did it. Thank you for all your help. That is the rest of our circles questions. We are done for today. We're going to be back tomorrow, 7 o'clock. Be here or be squared. I don't know if you're here tomorrow till 7. You might be. If Freddie's here, he'll be here too. Tomorrow is going to be a longer day, though, because we are going to be going over Unit 5, volume, density, and modeling. So it is a longer day for sure. Please ask your parents to check their email so they know what's going on, and we will see you later. Bye-bye, guys. Ciao. Why is it not letting me click goodbye? There we go. Bye. We're done. Okay, so let's let Daddy know that we're done so I can bring you to Walmart instead of him having to come over here.